Okay, so let's talk about it. Last class, we talked about patterns, right? We were able to look at a lot of patterns. How much did we go from the first term? Did it decrease? Did it increase? How did it increase? How did it decrease? Today, we are actually going to find that value and actually start implementing it into what eventually will be an equation to find any term, any value in a sequence. But before we can do that, we need to be able to find either the common ratio or the common difference. Let's talk about which is which. In your vocab, we talk about two very specific sequences. Arithmetic sequences, or arithmetic, however you want to pronounce it, both are the same. And geometric sequences. Now, which is which? For arithmetic sequences, there is a difference between them. As I go from the first term to the second term, to the third term, to the fourth term, the way they increase or decrease is the same, right? And you can see this by one operation. We can either add a positive value to the first term to get to the second term, or we could add a negative value. And I know it might feel counterintuitive to say, oh, I'm adding a negative number. Don't I subtract? Not for sequences. For sequences, we are only adding and going to the next term. Whatever we add, whatever the difference is, we need to add it to get to the second term, to the third term, to the fourth term. Okay? So if we add a negative number, okay. In our minds, we're okay. I'm just subtracting this amount. But on paper and on an exam, if you see the difference, we are adding it always, okay? So again, we talked about common difference, right? This is the difference between two consecutive terms in an arithmetic sequences. We only see differences in arithmetic sequences. And this is represented by the letter D. D as in difference, right? Okay. Now, let's talk about the other sequence that we will talk about in this class, a geometric sequence. In a geometric sequence, there is a common ratio between any two consecutive terms. So here's what we're going to do. We are now going to multiply by a positive value or by a negative value. Within those two, whether it's positive or negative, we're going to either multiply a whole number or, anybody remember what ratio means? Ratio, rational number. That's where we get that from. In a rational number, what do we get? What type of number is that? Ring a bell? Talked about it. A good chunk of it in elementary. We brought it back in middle school math, specifically in 7th grade. A rational number. Maybe we've seen something like this. That is a rational number, everybody. This is a type of relationship where it's a number divided by another number or a fraction, right? That is a rational number. Whole number could be easily as 2. Rational number could be 1/2, right? But nevertheless, if I'm multiplying it, that's how I'm getting to the next term, right? Could be positive, could be negative. Here, let's do some critical thinking. Within your groups, talk to me. If I were to multiply by a whole number, let's say to 1. Let's start with the number 1. And then for the next sequence, let's start with the number 1 as well. I want you to find the remaining terms. Let's do 4 terms. If I were to multiply by 2, and for this other sequence, this other geometric sequence, I want you to multiply by 1/2 and find the next 4 terms. This is just so you can make the connection yourself. I'm going to give you 2 minutes with your group, starting now. what happens? What are the next 3 terms? Keep it in a fraction, everybody. I want to keep it in a fraction. I don't want decimals. I want you to keep it in a fraction. Believe it or not, decimals serve us no purpose in this class, really. We use fractions more than we use anything else. So what do we get? If I were to, so the first one's easy, right? If I multiply each one, 1, 2, 4, 8. What about the next one? 1, if I multiply by 1 time, what do I get? What? 1 half. Okay, if I multiply 1 half by 1 half, what do I get? How do you multiply fractions? So then what do I get? Okay, so then if I multiply 1 more time, what do I get? 4 times 2 would be... Alright, everybody, let's talk about it. First one's easy, right? 1, 2, 4, 8. Cool. For those of you that have forgotten how to multiply by fractions, the first one, 1, the next one is 1 half. Cool. And again, for those of you that have forgotten how to multiply by fractions, we just multiply fractions straight across. So my next term in the sequence would be 1 over 4, and the next one will be 1 over 8. Beautiful. What have you noticed? When I multiply by a whole number, my numbers get what? And when I multiply by a fraction that is less than 1, my numbers get what? 30 seconds, talk about it with your groups. What you get? Someone that hasn't interacted with me today. When I multiply by a whole number, what happens? Okay, so the number gets larger. That's important. Okay, someone else that hasn't interacted with me. If I multiply by a fraction that is less than 1, what happens to the rest of the term values? Violet, what do you got? It's decreasing. So over here gets larger, we're going to put increasing. That is important, especially in your homework assignment. Being able to tell the difference. Oh, I see the numbers getting smaller. Oh, it might be, if it's a geometric sequence, okay, I know it's going to be a fraction. My common ratio is going to be a fraction. Oh, if my numbers are getting bigger in the geometric sequence, oh, I know it's going to be a whole number. Just got to find which one, right? Can I answer any questions? Give you a couple more seconds. Okay, I have passed out a handout with sequences first. That's the only one I want you to focus on right now. I want you, with you and your group, for the next 5 minutes, actually let's bump it to 7. For the next 7 minutes, I want you to fill in the next two terms of the sequence. That implies a couple things. Number one, you have to find the common ratio or the common difference. And number two, it has to work throughout the entire sequence. So, 7 minutes, talk about it. What is the common ratio? What is the common difference? Is there either or? And then fill in the next two terms with whatever pattern you and your group have come up with. So, 7 minutes on the clock. I'm going to be walking around. Go. Arithmetic version. Now what's R? The ratio. What? Everybody, real quick, I want to clear up something. Let's go back to the vocab just for a few seconds. Everybody up here. When we're decreasing, right, it could be negative numbers, right? In that particular instance, just cover the negative when we're thinking about increasing, decreasing, right? For example, and I just want to review the one that you're doing right now. The first one, although the numbers are decreasing, the number value itself, we're going from 2 to 6 to 18 to 54. The numbers themselves, right, we know would be increasing if they were positive, correct? That is how I want you to think about it, right? Because if you think, oh, well, I just need to multiply by 1/3, well, that wouldn't be true to get to the next one, right? So just, we know that the ratio is going to be what number? What's my ratio, my common ratio for this first one? 3, right? I'm multiplying by 3 every single time to get to the next term. That means that my next one is going to be negative 162 for that, and then my final term is going to be what? 486. Good. So although the value is decreasing, the numbers themselves, in order to go from the first term to the second term, I have to multiply by 3. So in that particular instance, just kind of not worry about the negative number and the value specifically of the number. Okay? All right, keep going. How are we doing, everybody? Which one are we on? B? Okay. What do we see? Okay, they're going by fractions. Okay. So what's happening every single time? Okay, so the denominator, you see a bunch of them are 4. So then maybe convert all of the numbers into the same denominator, and then let me know if you see a pattern. Let me know if you see a pattern. If I were to convert all of those numbers into the denominator of 4. Do you see a pattern? Question mark. Yes. What do you see with B? Kind of hard to see, right? It's decreasing. Okay, we're good. So it's some type of sequence that's decreasing. How do you think about what you see with numbers? What do you notice about some of the numbers? Okay, and the fraction, talking about the fraction. Have you noticed anything? What do you notice about some of the fractions? What is the denominator? 4. What if, just thinking, what if I were to create all of them to the same denominator? What's the same pattern? So if I wanted to make that whole number 4 into an even common fraction, what would I need? What would be the fraction? So the denominator would be 4. Alright? What would be the numerator? Divided by 4 is going to equal number 4, right? Okay, so we need 4, 8, that would be 2 times 12, that would be 3 times 16, so 16 divided by 4 will equal the same thing as whole number 4. 16. Okay, so now you see 16 over 4, 7 over 4, 1 over 4, sorry, 1 over 2, but I convert that into 2. Is that the denominator of 4? Yeah. So, with that, they're all 12 and nothing, right?
Oh, negative 11.
So, basically, we negative 16 divided by 6. So, from 16 to 7, negative 2 is 16. Now, you have to negative 11. Is there a pattern?
Sorry, I'm going.
Okay.
Talk to me about some of the fractions that you see. Okay, so what do you know about some of those fractions? Do they have anything in common? Some of them negative, so they want to let it, you can see that some of these fractions have in common. Okay, great, that's great. If I keep all the same denominator, I can potentially see a pattern, right? So how would I convert the positive 4 into okay, talk to me. I need a numerator that's divided by 4 will give me a number. So I need a number that 4 goes into Any more time? Yes. Alright. I'm going to give you up because I really want you to talk about this and find the patterns. This is the tough part of today's lesson. I'm going to give you another 7 minutes. No, just 7. Okay. So the first thing is 7 over 4. Don't want to have that over to be denominator of 4. You can't manage 7.
Negative minus 4.
Is the top. They're decreasing by 1. By 7.
Oh yeah, that's what equals plus or negative 1. Plus negative.
What do we end up with? B. Okay. Talk to me. What do you notice about some of those fractions?
Switch all of them.
You might see a pattern.
4, 7 over 4, negative 4, and negative 1.
So maybe all, because not all your group has that information. And supplement.
Okay, so we're all write it down. Okay, write it down on no paper release.
Yes, but not just like the 9.
I know I gave a whole list of at least 3 times.
Right? Spend a lot of our time subtracting against what is the denominator. Yes,
Everyone,
not just
please
9.
write
It would
this down.
be 9 over. Yes.
Negative, or no, 16 over 7 over 4. Negative 1 over 7 over 4.
I would do B.
Negative 2 over 4.
No worries. Talk to me. What do you see about some of those fractions?
Negative 11. We have all that. Yeah, we have that. Thank you. Okay, do you have all my work?
So two of those fractions have a denominator of what? Okay?
Okay, yeah,
What if
so that's negative
all of the
9.
numbers that have a denominator of 4? Maybe I can say negative. What about a negative 4? If I have a negative 5, 4 and 4 is 11. So I need to add 16 over 4, right? So then you get 16 over 4, 7 over 4, 2 over 4, and 11 over 4. Can you now see a pattern?
I didn't even know you could add negative 1. It just said,
Yes, but are you adding the same thing to every single time? That's the only way it can be arithmetic, right? Geometry. What? Are you multiplying the same thing every single time? No. So if you can't add the same thing every time, you have to multiply it. Sometimes that we talked about. Have we talked about it? So that it's not.
What did you say it was?
It's as simple as that.
Well, because each goes like, from going to the next one, it has to be, or from going to 2, the next is H, and to go from like, let's say these are the 4 numbers for H, right? R is these colors, right? Yeah, to go from 1,000 to the next is this would be negative 4.
Yeah, so
No, 0.5. And 7.
I asked you, and then do that same pattern.
Exactly.
Okay.
0.2 plus 5 equals 7. 7 plus 5 equals 12.
It follows this way.
1,372 plus 1,372.
Oh my god, you said that.
Wait, what? Okay, but it's still goes down by 1 inside. Exactly. You get my point now? Yeah.
All right, everybody, here we go. Let's come back. Let's come back. Okay, I hope, real quick, something that I'm noticing on your pages. Some of you keep writing R for all of them. That's not true. What does R represent? Ratio. And that only exists in what? Geometric sequences, right? Where you know for certain that you multiply throughout the entire sequence, right? So you putting R everywhere is not going to cut it, especially on an exam, right? Or especially on your homework assignment. It's not going to cut it. And so this is for geometric. The D represents difference in what type of sequence? Arithmetic, arithmetic, whatever you want to call it. But just know that this is where it belongs. You have to know the distinction. Difference meaning you are adding some type of number to get to the next number in the sequence. Okay? So let's talk about this one. B. A lot of us needed my help with it, which is perfectly fine. What did I tell you to do? Yes, if I converted everything into the same denominator, into all fractions, I can potentially see something. So 16 over 4 was the first one. 7 over 4 was the next one. Negative 2/4 is the next one. Negative 11 over 4 is the next one. What did we find? Is this an arithmetic or is this a geometric sequence? Arithmetic, right? So that means I am looking for a difference or a ratio. Difference. So this should be the letter D. What is my common difference for this sequence? It's what? It's not 7 over 4. Oh, sorry. It's not 9 over 4. It's what is it? It's not 9 over 4. It's negative 9 over 4. Yes, okay. Shh, real quick. We talked about this at the beginning of class. We are adding values. We are not subtracting when we're going to the next term. We are adding. So if we need to add a negative number, then that's what the difference is. We're not subtracting. We are simply adding. So yes, if you're strung out by me saying, oh, it's negative 9 over 4, that's the difference. It's because you forgot that we can only add numbers. We can't subtract in a sequence when we're trying to find the next term. So yes, this is the answer. Can I answer questions about this one? Okay, let's go with C. C has a weird pattern. My question to you is this arithmetic or is this geometric? It's neither. What is the rule for an arithmetic? We need to continuously do what operation and it work? Add. We need to continuously add a number and it works. Is there anything I can add to get to negative 2? Yes, I could technically add negative 3. But does that work when I go to the next term in the sequence? No. So then it can't be arithmetic. Okay, let's try geometric. Can I multiply something to get to negative 2? Yes, I could multiply negative 2. But does that rule work when I get to 3? No. So this isn't geometric either. So this is neither. But there is a pattern happening though, right? A very interesting pattern. What's my next number if I'm going based off this pattern?
5.
Positive or negative?
Positive.
Positive. Good. What's my next number? Negative 6. Good. Even though it's not following an arithmetic or a geometric sequence, it is still kind of important. Hold up. Let me make sure that my mic is on. Yep. Good. It is still important that I can still see some type of pattern, even though we're not going to use it. Okay, let's talk about letter D. Arithmetic or geometric? Arithmetic, whichever one you want to call it. That means there's going to be a common difference. What's my common difference for this sequence? It's positive 4. I am adding 4 every single time, right? Negative 20 plus 4 gives me negative 16. Negative 16 plus 4 gives me negative 12. And I keep adding the same thing. This means this is an arithmetic sequence. What are the next two values? 0, and then what's the next one? 4. Good. Okay. What about the next one? I like this one. This one's really cool. I'm going to do something, and I'm going to give you 30 seconds if your group didn't actually figure out. What if I do this? Can you now see a pattern? I'm going to give you 30 seconds. Talk about it with your group. Let's do 1 minute. What am I either adding or multiplying to get to the next number? What is this one? Yes. All right, buddy, here we go. What did you and your groups notice? It's multiplying by 1/2. Let's test it. So 5/1 times 1/2. What did I say about fractions? We can just multiply straight across. So this turns into negative 5/2. Okay, let's see if this trends. Negative 5 divided by 2 times 1/2. What do I get? Negative 5 divided by 4. Look at that, it's trending. And if we keep going, we're going to experience the same pattern. So this, in fact, is a what type of sequence? This is a geometric sequence, meaning there's going to be a common ratio. What's my common ratio here? We said 1/2. Okay, so then what are my next values? It should be negative 5 divided by what? 16. And then what's my next one? Negative 5 divided by 32. How are you feeling, everybody? Can I answer questions? Please ask. I'm begging you to ask me questions here. Please. This is hard stuff even for me. I struggle with it sometimes. So if I struggle with it, I can't imagine you not struggling. Don't sit there in silence. No? All right then. All right. Let's talk about F. Going from 86 to 85, there's really only one operation we could do, right? What is it? I could subtract 1. Sorry, I can add a negative 1. That was my fault. My bad. I can add a negative 1. But does that trend follow when I go to 83? No. So could this be arithmetic? No, it can't. And I can't think of any number that I could multiply this to get to the next number. Can you? I'm struggling too. So what do you think? Is this an arithmetic geometric sequence or is it neither? It's neither. All right, let's do G. Yes, real quick. That was a great question. Can we, finding the pattern though, can we? Yes, we can. I know I'm going down by 1 here. What am I doing on the next one? Going down by 2. What in the next one? I'm going by 3. What about the next one? So then the trend would be that the next one I'm going down by 5. So this should be, okay, then the next one should be what? Should be 60. 65? Right, because I'm going down by 6. All right. Now let's do G together. G. I'm going from negative 16 to positive 4. Let's talk about it. Could I add something to it? Yes. I could potentially add 16 and then another 4, 20. I could add 20. But does that follow, if I add 20, will that get to, sorry, I'm going too fast. If I add 20 to positive 4, will that get me to negative 1? No. So could this be arithmetic? No. But could I multiply something? What could I multiply to negative 16 to give me positive 4? 4. So here, put this in your calculator. Negative 16 times 4. Is that going to give me a small number like 4, or is it going to give me a massive number? It's going to give me some big number. I don't want that, right? I need to somehow multiply something to get it to positive 4. What do you got? Negative 1 over 4? Let's try it. Negative 16 times negative 1 over 4. Okay? Negative times a negative is a positive. So 16 times 1 is just 16. Okay? And then 1 times 4 is 4. 16 divided by 4. We actually talked about that in part B. What do we get? 4. So far, this trends. Negative 1 divided by 4. Okay. Let's just test the next one. See if we get it. 4 times negative 1 divided by 4. 4 times negative 1 gives me what? Negative 4. And then 1 times 4 gives me what? 4. Negative 4 divided by 4 would be what? Not 1, negative 1, which is exactly what we have here. So it seems like it is following this pattern, but we're having to do what operation to get to the next term? Are we adding something or are we multiplying? We're multiplying. So what is this, a geometric or arithmetic sequence? It's a geometric one. So that means this is going to have a common ratio. What am I multiplying every single time? Negative 1 over 4. All right, here we go. For H, arithmetic or is this a geometric sequence? It's a what? Arithmetic sequence. What does this mean? It means that means I am adding some particular value. What am I adding to get to the next term? Negative 20.5. Does that work for each one of them? Yes, it does. So then what are the next two terms in the sequence? It should be 1,300 and what? 90? 91? 90.2. Okay. And then what's the next term? 1,370. This should be 391. 1391.2. And the other one should be 1,370.7. That's good. Okay. Questions, anybody? Can I answer any? Are you confused in any part that I can help clear up now before it snowballs? Okay, let's do an in-depth view of how arithmetic sequences work. Okay? Remember, we are always basing off the previous term when finding the next term, right? So, for example, let's consider this. And the reason I'm going to go in depth is because this is going to help us in our next lesson. We're going to be using sequence notation, and you have to know what each thing represents. So in this case, consider this sequence. A sub n is the next term in sequence, or any term. I think I'm going to write any instead. This is any term in the sequence. That's what a sub n represents. Now, here's the next part. A sub n minus 1. Again, these are not operational. Those sub values underneath don't mean anything as far as operational wise. But what it does mean is this one is the previous term. And then finally, this represents my common difference. Okay, so let's elaborate on this. We are told that a sub 1 is equal to 11. So what does this mean? A sub 1 means it's the first term in my arithmetic sequence. Okay? Again, a sub 1 is the first term in my arithmetic sequence. A sub n means any term in the sequence. Could be the next one, could be the third one, the fourth one, could be the 100th one, could be the 6th, 7th one. No? All right. Okay. All right. So, let's use our knowledge of how arithmetic sequences work. In this example, I want to find the second term. Okay? So, what I need is, I need to find the value of the previous term and then add -2. Well, we know what the value of the previous term is, right? We said that that is equal to 11. So then 11 plus -2 gives me +9. So far we have 11, 9. Okay, so then when we're talking about the third one, we're going to need the previous one, and we're going to add -2. So then we get 9 plus -2, which gives me 7. So then my next term, my third term in the sequence is 7. Obviously, you could do it yourself, right? You're like, I'm Mr. Jones, I don't need that. Like, I can just keep going. Trust me, this is going to play big in when we connect tomorrow's lesson, or Thursday's lesson, sorry. This is called sequence notation, which we're going to need for our next lesson. Because next lesson, we're creating equations to find the 1,000th term, or the 120th term, right? Instead of you going, okay, let me add -2 100 times. Like, who wants to sit there and do that? This is why I want you getting comfortable with this, right? Understanding how sequences work. And if we're going to find the fourth one, we're going to need the previous one, which is the third one. And now we're just going to add a -2. So we're just going to get 7 and add -2. This will give me +5. So for this sequence, all we've done is we've gone from 11, we've added -2 to get to 9, added -2, added -2. So then we can say that our common difference is -2. This is a worked through example on how arithmetic sequences work. Are we ready to try it? I want you, this is straight from your homework assignment. I want you to find the common difference of this arithmetic sequence. When you're done with that, I want you to find the 10th term. of that sequence. I'm going to give you and your groups about 3 minutes for you to complete this. If I can find my remote. Oh, I know where it's at. Oh, I guess not. All right, go ahead and start. Pound it. Yes. About a minute and a half, everybody. The answer is that is this street. Yes, if you're ready for it, do example 3. For this one, yes. That is the first term, yes. It's always whichever number is at the beginning, that's your first term. As long as you know how to do it, it's perfectly fine. All right, everybody. What does D equal? So it's 9. Good. Okay, so let's talk about it. 11, comma, 20, comma, 29, comma, 38, comma, 47, comma, 56, wait, no. Yeah, 47, 56, comma, 63. Oh, yeah, sorry, 65. 65, comma, 74, comma, 83, comma, 92. It's the first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, and 10th term. So my answer is 92. That is the 10th term of that sequence. Okay. Now that we have a handle on it, I'm going to give you a minute and a half for the next one. Shouldn't take you that long. So, 90 seconds, go. everybody, here we go. So what's my common difference here? What is D equal to? 7. Okay, I agree. What is the 20th term then? 129? All right, let's do it real quick. -4, 3, 10, 17, 24, 31, 38, 45, 52, 59, 66, 73, 80, 87, 94, 101, 108, 115, 122. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 129 is my 20th term. How do we feel, everybody? Good. Okay, I want you to do something real quick before we move on to geometric. I want you to take a look at the graphs now that I gave you. I want you to take a look to see which one of them matches the specific sequence that we talked about. Right now, we're only looking at arithmetic. So what are we doing real quick? What is it that we keep doing to the number? We keep adding a number. Do we change rapidly, quickly? No. What are we doing? We're going at a constant. We're either going constantly up or constantly down. Which one of our parent functions did we talk about that constantly moves? Our linear function. So that's my hint to you. Match the correct arithmetic sequence that you have with the correct graph. I'll give you 2 minutes for that.
Are we matching graphs from here with sequences?
Mm-hmm. You're matching the graph that I gave you with the sequence that I gave you. Camila and Chloe's group, be prepared to share because I'm going to ask on you first. I'm letting you know now. Kira's group, you're next. I'm sharing your group. I want your group to share. Maybe you. And then Haley's group, you're the last one to share. It's okay, that's fine.
We don't do graph 2, 5, and 6.
We're only matching arithmetic sequences with their graph. That's all we're doing right now. All right, everybody, here we go. Talk to me, Chloe's group. I want you to match one of the graphs with the correct arithmetic sequence. Let's talk about graph 1. Which sequence matches with graph 1? Don't take too long. Yes, I'm asking you to match graph 1 with the correct sequence. All right, Kira's group, which one matches with graph 1? We said sequence B. Class, do we agree? Yes? No? Yes? Are we saying that graph 1 matches sequence B, their behavior? I agree also. This is correct. Okay. Let's try Camila and Chloe's group again. I want to match graph 3 with the correct sequence. Which one is it? D as in dog? Class, do we agree? Does it match sequence D? Yes, it does. I agree also. All right. Haley's group, you're up. I want to match graph number 4 with the correct sequence. Which is it? Anybody from Haley's group? Think about where the numbers are. It's all the way up in... I said graph 4, yes. We're saying sequence H. Class, do we agree? Is it matching sequence H? Absolutely, I agree also. Very good. Okay, with my limited amount of time with you, I want to cover geometric sequences very quickly. So, just like arithmetic sequences, the notation is very similar. When we are looking at the nth term or any term in the sequence, we have to look at the previous term, the g sub n minus 1, so previous. And then we multiply it by the common ratio. So we do this every single time. We go to the previous one, multiply it by the ratio, we get the next one, so on and so forth. So here we go. For a quick version, we are told that g sub 1, so the first term in the sequence, is equal to 1. According to this, the common ratio is 2. So what does that mean? We're going to multiply the first term in the sequence by 2. So the first term in the sequence is 1, and we're going to multiply it by what? 2. So what is the second term of our sequence? 2. Good. Okay. Now we're going to find the third term in the sequence. That means we need to multiply which term in the sequence? The second term by what number? 2, right? So we need to multiply the second term of the sequence by 2. This will give us the third term. So the second term in the sequence is 2. We multiply it by the common ratio. This gives us the third term of the sequence, which is 4. And again, I apologize that I am breaking it down this way. It's going to make sense on Thursday. I promise. Okay, last one. In order to find the fourth term of the sequence, we need to multiply the third term of the sequence by 2, the common ratio. So the third term in the sequence we just established was 4. And we're going to multiply it by the common ratio, which is 2. This gives us 8. So our sequence is laid out exactly like this. 1, 2, 4, 8, so on and so forth. That is how we do geometric sequences. Okay. Straight from your homework assignment. Find the common ratio for example 2 and example 3. I'm going to give you and your groups 3 minutes. And I want you to find the 6th term for example 2 and the 8th term for example 3. So, I'm going to give you 3.5 minutes starting now. All right, everybody, here we go. What is R equal to for this example? 9, okay? So then what's the 6th term here? I'm going to take your word for it. Are we okay, everybody? Yeah, good. Okay. Find the common ratio for this geometric sequence. What is R equal to? 1/4. Let's test it. Negative 128 divided by negative 32. What do we get? Oh, nope. I did that the wrong way. Nope. So real quick, everybody, for those of you that are struggling to figure out how to find the difference if we're decreasing, here's what I like to do. I like to divide the 2nd term and divide it by the 1st term. This will allow you to get some type of ratio, right? and then use that ratio to see if it follows the rule. So the second term is negative 32. The first term is negative 128. When you put it into your calculators and you reduce it all the way, you get 1 divided by 4. How do we feel about finding that way using the how do you feel about finding the geometric ratio using this method? I like it. It's a good way to check. Okay, so let's check it. Negative 128 times 1/4 gives me negative 32. Okay, so what's up? Sometimes you'll be told to determine it yourself. On your homework assignment, I have a specific section where you are tasked to find whether or not it's a geometric or an arithmetic sequence, because I want you to focus on that. Okay? Some of the exam questions might tell you, but focus on you making that deduction yourself. The way it's decreasing. For example, this one's decreasing pretty quickly, right? We went from 128 all the way down to 32, and then to 8. When we were talking about arithmetic sequences, they were just kind of climbing steadily, constant, right? So those are the kind of the things that you should be looking for when you're looking at a sequence. Does that answer your question? Fantastic. Okay, so then what's the 8th term of this geometric sequence? Well, let's take a look. So negative 128, negative 32, negative 8. The next one turns into negative 2. Next one is negative 1/2. Remember, everybody, keep fractions. Fractions, I know you might not like them, but they are way more useful to us in this subject area rather than decimals. Next one is negative 1/8. Next one is negative 132. And the last one is 1, 2, 3, 4, 5, 6, 7. Yep, negative 128. 1 over 128. Okay, very quickly for the next 30 seconds. What are we noticing when we're talking about geometric sequence? We are changing at a constant, or are we changing very quickly? Very quickly, right? And which one of our parent functions changes very quickly, whether it increases quickly or decreases quickly? An exponential function. For the next 30 seconds, match the sequences from the beginning of the lesson to their corresponding graphs. 30 seconds. Now. Okay, so I'm looking at graph 2. Someone share with me, which sequence does graph 2 belong paired with? Anybody? Graph 2 looks like we're decreasing very quickly in value. Which one of those geometric sequences decreases very quickly in value? G? A. I'm going to agree that this goes with sequence A. Okay, let's talk about graph 5. This pairs up with which sequence? Anybody? Yell it out. D? I think this matches with E much better. Because we're approaching what value as we keep going? 0, right? We keep climbing from -5 all the way close to 0. Okay, last one. Graph 6 will pair up with sequence G. Real quick, everybody, as you are packing up, think about this. Mariana and Ashley are beefing, right? And one of them is saying that if the first two terms for 3 and 6, she says that she wrote it like this. Ashley wrote it like that. Who's right?
Well, it depends on if
Arithmetic or if it's geometric, right? Because are they both right? Yes, they're both right. Absolutely. Okay, everybody. That's it for now. Go ahead and pack up. Yes. Yes, let me deliver them to me as you walk out.